We are going to start with another session on Python programming basics. After learning the variable declarations, operators, conditional statements, and loops, now we are moving ahead with data structures in Python. And there are three important data structures on which we'll be working today. That includes list, dictionaries, and tuples. These three names we'll be using technically with Python programming one by one, and I'll explain in which conditions any one of these data structures you may use as a beginner or while handling your patient data or in general wherever you are working on Python programming. So starting with Google Colab directly, I'll be creating the very first instance that is for lists. So the first main category I'm writing here is lists in Python. Yesterday, I have shown you one example of list, how we create them or how we can use them. So list basically help you to organize a number of values into a single variable. Like till now, whenever we did variable declarations, we were using them with single values, something like this. Single values every time we were declaring, like name declaration we were doing. So in that case, we were writing something as a name within inverted commas. So only single element declarations we have done till now. But in case if you have multiple values to store in a single variable, that could be maybe names of the patients, or maybe some readings about the patients, or maybe any other event from your day-to-day activities. If you just want to store a list of those events, means more than one events to be organized in a single variable, then we prefer using lists for that. And in order to create a list, the process is very simple. I'm first writing the task here, creating lists. That is our first task we'll do here. Lists are always created within square brackets. That is the first point you need to understand. Like till now, the variable declarations, normal variables we have declared, numbers and floats you were writing directly, strings you were writing within inverted commas. Now we are learning how to write list, and for that we always use square bracket. And within this, we can insert any number of values as per our requirement. So this list currently contains 6 different elements. And these elements are stored with a comma separation. Based on this, now you can check the values of this list. Like if we present it here, these numbers will be updated into your storage, and we can see them like this here. Now, this case, you can observe that I have created all the integers into this list. So this we can call as list of integer elements we have created first. I'll be also creating a code share window for all of you to get codes side by side. I've shared this link in the chat box. So whoever needs this in between, they can use it here. For the lengthier codes, I'll be pasting them in this section. And for the shorter one, definitely you can do yourself side by side. Now let us see one more part. Maybe I need to declare names within a list. So how we can organize them? I can write names something like this. The inverted commas, you can use single and double any, no restriction on that. but just comma separated sequence we have to use, and these will be your string sequences that we can store something like a list here. And a list can contain any number of elements. And the most important part here is that we can change the elements of a list. Like once I have created any list, something like this, later on, if I need to change any value, like maybe after a day, I observed that here the value 10 should not be there, there should be some other value. So it is possible to change values of list. That is why, in technical terms, we call that lists are mutable. Lists are mutable. This is a technical definition we give for list. Mutable means when we can change the elements of that existence as per requirement. I'll show that further to you, that how we can change those elements. It is not like I'll be updating value here. It is about once you have created list, then after that you can change values to that list after creation. So we will learn that further, but this is the basic definition, that lists are always mutable. We can make changes to their elements. Now, the second list we have created here, we call it list of string elements. In the similar manner, you will observe here, we can even create list of mixed elements. That is also acceptable. We will not get any error in that. For example, I'm writing these three different types of values in a list. A mixed list I'm creating, for example. So we can have a integer, we can have a string, and we can have a float also. Still, it is acceptable. You will not get any error in that case also. So we can write here a list of mixed data types. Data types basic we have learned on the first day of Python programming, that included integers, strings, and floats, etc. So the mixture of that is also possible. So these three different codes tell us the simple versions of element collections. Later on, when you have patient data, like maybe 100 values, 200 values of patient temperature reading, or maybe patient heart rate readings, you can organize them all into such type of lists. So in that case, you can directly create lists of maybe heart rates, and you can fill them into these entries directly. So some random values, for instance, if I'm writing, this could be your list of heart rates. Similarly, some other patient vitals you may be collecting. So that also you can put up in sequence. There can be combination of data types or simple data types. Maybe another vital of the patient you are collecting, that is the step count uh, of a patient, daily step count that you may be gathering from some variable sensors. So that kind of any large values maybe you are saving. So there could be a range of vitals that you can store now. For example, I created these 3-4 lists just to save patient vitals that I'll be using further for different types of analysis. So I have just initially created few lists over here. One time and again, I'll be using for different purposes ahead. Just some samples we have updated. So in this way, any number of patient vitals you can collect. Later on, we will also learn that how combined patterns of these patient vitals can be processed in Python. So for that, we'll be using Excel sheets in coming days. But currently, we are talking about list elements that can store individual variables one by one. Let me know if the basic understanding about list is clear. Then we will start some operations on list. You can let me know quickly in the chat box. Link to CodeShare I have given already in your Zoom chat window. But if it is not accessible from here and you need it in WhatsApp group, just give me a second. I'll stop sharing screen for a while and I'll share this link in WhatsApp group as well. Okay, so I have shared this link in WhatsApp group also if anyone needs. This may be fine. And now I'll be sharing these variables as well here, the range of variables that I have created, and I'll be using them further for different analysis. Let me know if everyone is good with the basic understanding of list. Just a very simple concept we have learned. Okay, great. Now the next task I'm doing here is to access values from the list. For example, these different types of lists I have created. And currently we are having only 5, 6 values in this list. But originally when you will be working on real data, maybe you will have thousands of values in list or maybe hundreds of patient values, vitals you will be recording in the list. So in that case, in order to access information from specific areas, like maybe you need to know about patient number 10 vitals directly. So you will be able to access patient values directly from the list in that case. And for that, we take help from indexing. So I'm writing here a comment using indexing to access list elements. And as we have learned earlier, that indexing are possible in 2 ways. Can anyone recall what we discussed about indexing? What 2 different types of indexing are possible? Just a quick update if you can give in the chat box. I can see some responses. Yes. Anyone else? If you remember, I discussed about 2 types of indexing that were positive and negative indexing. So left and right side is also fine, but technically we call them positive and negative indexing. So positive indexing starts from left to right, negative indexing starts from right to left. I hope all of you can recall this thing because this will be using to access elements from a list now. So what I have done now, maybe certain list I have created with a range of elements that may be like 22, 34, 45, 78. Maybe these are 4 elements of a list. Now, these individual elements will also have a indexing, same as we have seen with the strings, etc. Everything has an indexing because this is the storage sequence, how something is getting the storage sequence in your memory. So if I talk about positive indexing in this case, so it will start from here and it always starts from 0, 1, 2, 3. So this is how individual elements will be marked in that case. Similarly, negative indexing starts from this side and always from -1, -1, -2, -3, and -4. These are the 2 ways to extract these elements. So in this way, you can have any number of patient values and they all may have individual positive and negative indexing. So based on this, if we need to extract certain values like heart rates variable we have already stored, maybe I need from here the heart rate of third patient in the count. Third patient I'm talking about. Can you let me know how I can extract the heart rate of third patient? If anyone can remember how we can do this thing from any earlier examples, just give it a try, any random try. We need it for the third patient. I can see different updates in the chat box. So when I'm talking about third patient, notice this very carefully now. When you are writing your own handwritten, maybe patient data you are preparing, so you may be creating some sheets, like maybe a heart rate sheet you are creating, and you have patient ID P001, P002. Generally, this kind of values be put for the patient IDs, maybe. So P1, 2, 3, 4, we are writing here. Now, heart rate values for patient 1, I'm writing maybe 85, then maybe 72, just some random values only I'm putting, maybe 76, maybe 94, this type of values. For any number of patients, maybe we can we can create here. Now, manually, when you count it, for you, first patient is this. This is your first patient. This is your second patient. This is your third patient. This is your fourth patient. This is your fifth patient. So maybe when you are summarizing your research, maybe your supervisor suddenly asks you that tell me the heart rate of third patient. So naturally they are meaning this one, third patient, because as per your manual count, this is your third patient. But now consider in terms of indexing. In terms of Python, if we talk, the first indexing starts from 0 in case of positive indexing. First indexing starts from 0 and so on, 1, 2, 3, 4. So Python stores 0 onward, but your reference is 1 onward. Now, considering this difference, tell me, in order to access heart rate of third patient, what index value I should access? Yes, great. Now you know the difference. So now we need to think in terms of Python because values are stored in that, and we need to think in terms of the memory storage that is allocated to it. So now in order to access this value, we need to go ahead with second index value. So for this, what I'll write is going back to this point, and I'll write here 2. And now if I check the outcome, that is 95. So this is your zeroth value, this is your first value, this is your second value, which belongs to patient 3 in your case. So this difference you have to keep in mind. When you are accessing things from Python, you have to follow rules of its memory indexing. That is much important. Now, in the second case, let us do the similar kind of thing with the help of negative indexing. Positive indexing we have tested. Let us learn the same thing with the negative indexing also. Maybe your supervisor is asking you to get temperature of second last patient. Temperature value of second last patient. So, how you will write that in Python? Give me the complete code now with the variable name and with the indexing. We are talking about temperature value of second last patient. Try to give the entire code with variable and index value. Yeah, looks fine. So if we are talking about heart rate, then definitely you will write heart rates -2. But as I'm asking about temperature, so you will be taking temperature. And also I have asked about negative indexing. So you will start from the back side now. So this one I have written here is using positive indexing. And second one I'm asking you is from negative indexing. So negative starts from backside and it will be -1 onwards. So to get second last patient value, I'll be writing here -2. I'll write here using negative indexing. Let me know if this point is clear, why I'm using -2 here. If anyone is confused, this may be easier now. Okay, great. So it is just a simple concept we are using. -1, -2, -3, -4, and -5. Now, this way it will go. Earlier, we were using this way. So after this, there is one more important technique we can learn that we call slicing operation. Slicing of list elements. This kind of things are also several times required. For example, you are recording 10 patient readings per day and you are getting data for a week, 7 days. So maybe you are creating a list of entries every day for those 10 patients. Now, chances are that maybe sometime we can call it, like I'll be preparing it here for 10 patients you are collecting data every day, and now this could be range of values you are updating. So this kind of values possibly in every hour or maybe within a certain details you are putting up these kind of values. Now maybe for your further analysis, like you may have thousands of such values, or maybe in 7 days you have gathered maybe 100 values. So supposing that you have maybe 10 values per day, maybe 10 values per day you are gathering, and now your supervisor asks you that give me Wednesday readings from that entire week. They just ask you that, okay, just tell me what are the 10 readings from Wednesday. Others, they don't want to see. So in that case, you know that I have 10 readings per day. So you may have 10 readings on Monday, 10 readings on Tuesday, 10 readings on Wednesday. Similarly, it will go on. So these 10 readings you may need to extract, for example. So starting from try to understand concept. I'm just relating it with your day-to-day practice. Implementation will be pretty easy. That will not be difficult. I'm just relating it with your requirements only. So starting with the index values 0, 1, 2, in such a manner up to 9 will be indexing of Monday in that case. Similarly, 10 to next 10 values, it will be considering for Tuesday, and so on for Wednesday. So indexing will be distributed in the similar manner. Now you need values from Wednesday only. You don't need this, you don't need this, and after this also you don't need. So you can slice only these values from your data also. Instead of using individual index element, you can slice an entire portion. So for instance, we are covering up to in this list. Now coming back to the existing list, like glucose list, I'm updating here. For this glucose list, considering that similar kind of example, maybe your guide is looking forward for only these values, these two values. We can slice them separately now. How we can do that? We can put the starting and ending limit. starting index limit and ending index limit. But there is one important thing to understand about it, that slicing limit, the way we put it and the way we use it, this is the way to write your slicing limit generally. Starting from this value, this is the start value of index, and this is one less than the end value, one less than the end value. This is another important thing we need to understand while slicing different values. So for instance, if I have a range of values, maybe 10, 12, 13, 16, 20, 21, and I need these two values only, nothing else, these two values only. So what I can write, considering the index 0, 1, 2, 3, 4, 5, now this rule we will apply. So it will become 2 colon 4, because starting element will be included and one less than the ending element will be included, so that is 3, so this will be also included. So this is how slicing will work. So for instance, if I have to apply it here for these two elements, the starting value is, if we consider, this is 0, this is 1, this is 2. So I'll write here 2 colon, and then we need this also. So 3 and 1 greater than this will be 4. So I'll write 4. And then if I try to visualize, those two elements are extracted. So if you need maybe the values for Wednesday only, so you will skip first 2 days entry. There will be 20 entries from first 2 days. They will be skipped. And after that, you will be continuing with the next 10 entries. That will be your Wednesday entries. So you can bring out Wednesday data clearly to your supervisor in that case. Let me know if this point is clear. No, you need not to count 4 from last. We are using positive indexing only. Let me show you again. We'll try this example again. I'll use this separately over here with little bigger sequence so that it gives you more clarity. So I have these number of elements. For example, they are 10 elements right now. Now, what I need is, I need maybe these 3 elements from this list of 10 elements. We will use positive indexing. First, we'll use only positive indexing. I'm not mixing yet. I'm using only positive indexing. So what is the index value of 180 right now? Index value of 180 is 2 right now because it starts from 0. So this is 2 right now. And what is the index value of 200? That is our last required element. What is the index value of 200 right now? Right, 4. So this is 2, this is 4, and we need data of these 3 entries. So I told you that the technique is, method is to use start index colon 1 less than the, or I'll write here in better manner. You can say 1 greater than the last required element. In terms of indexing, we can say it like this. Means you need to provide index of this so that 1 less than of this element can be recovered. This will be the slice sequence. If you need up to this, you need to provide indexing up to this. Yes, right. So based on this, what we can do now, I can write glucose 2 4 to 5, sorry, because we'll be recovering these 3 entries from this. So if I run this, you can see 3 entries I could recover. Just one greater than whatever value you have used, that you need to put in index, and the value recovery will be one less than the index. So both ways you can relate it. Let me know if it is clear now. We will do little more practice on this. Okay, because this is an important concept that you need to remember every time. Whenever we are using list, tuples, dictionaries, etc., everywhere this is used. So that is why we need to be clear with it. So now I'll give you a small task. In this glucose entry, I have already shared this sequence here. You can use it from here also to save time. In this glucose entry, I need, for example, these 4 values, and you need to use positive indexing. The task is extract these 4 values using positive indexing only. Take your time and let me know in the chat box. Okay, I can see several responses. So what we have to do is, I'll write here glucose 4, 8, 4 colon 8. And you can observe those 4 entries I could retrieve. These 4 entries I was looking forward to. How we are doing this? Check again. Those who are missing some concept in between, count from here. This is 0, this is 1, this is 2, this is 3, this is 4. So start value is 4. Then count further 5, 6, 7, end. So this is the end point 8, because one less than this value will be retrieved. So that is why these internal elements will take up to 8, so that up to 7 is recovered. Let me know if this is clear now. If anyone is still confused, let me know. Okay, no problem. I'll show this again. I'm just taking this entire sequence. I'll be putting it here. Observe this. This is our sequence. Now, let us first understand, because we are talking in terms of positive indexing only. So let us first understand how the index values are associated with it now. So this is 0th index, 1st, 2nd, 3rd, 4th, 5, 6, 7, 8, 9. So these are the index values right now. Now, the rule for indexing, I told you, is we need to put it in columns. First thing is you have to write within columns. Before column, you will have start index. Whichever element you are trying to recover, start index of that you need. And after colon, you will be adding index 1 greater than required value. 1 greater than required value you need. So if you know that I need to extract 4 values, maybe you know that I need to extract 4 values, and the ones that I asked you to extract were from here to here. These four values I asked you to extract. So means we are starting from this value. This becomes your start index now. And I'm telling you that if you need four values, 4, 5, 6, and 7. So 1 greater than 7 will be 8. This one. So ending index becomes 8 in that case. So that is why we are writing 4 colon 8, and it will recover four elements that will be index 4, index 5, index 6, and index 7. Let me know if this is clear now. I'll look forward for responses in the chat box. Yeah, this may appear illogical, definitely. But this is how Python works. Like I have shown you yesterday, range function also. We discussed range function also yesterday. In that also, I told you that it will have, if we are writing range 10, it will start from 0 to 9 in that case. So in that pattern only, majority of functions where start and end values are present, last portion is always one less than the given value that we need. So majority of functions work like this. This mainly happens because the counting in Python starts from 0. That is generally the main reason. The counting starts from 0. So generally, most of the logics are developed in such a way that one extra element is inserted in calculation. If it starts from 1, then maybe there could be a difference. But memory allocation by default is started from 0. So everything is developed based on that later on. Now, on the same sequence of elements that I have created here, for example, this glucose sequence that I create. Let us do one more exercise for better clarity. Now I'll give you one more task to retrieve from here. For example, this time I need values from this element to this element. Try this. You can use positive indexing. We are first learning positive indexing, then I'll come to the negative indexing. Take the reference again. I have added the index values. Yes. Now it seems that you are getting it. So what we can try here, let us see. Glucose, I'm writing. And inside this, I'm writing 7 to 10. So I'll try to retrieve the last three elements. Even if 10th index doesn't exist, still for reference we can use it, because by rule this is the way to use your sequence. So it will automatically cut it down up to the last element. For instance, observe here one thing. If I use it up to 11, 7 to 11, and I try to run it, still it will retrieve up to last element. Reason being, because after this, there is nothing to exist, because it will not be able to add any other elements further. So after that, even if some extra are used, still it is working in the similar pattern. But yes, general logic says that one greater than that we have to use, because that works universally with all the elements present. So that is how we are using it. I hope we are good with the positive indexing now. Okay, great. So now I'll take it with another reference value range. So I'm inserting more values inside just to increase its sequence. Now let us start with negative indexing. First thing, let us extract single element by using negative indexing. So task I'm giving you, use negative indexing to retrieve maybe this value from steps. I'll be sharing this so that you need not to write. I'm sharing this step sequence over here. So you can give me code based on that. We are trying to retrieve this value. Yes, looks fine. Now you people are getting it. So steps, I'm writing -3. So we'll be able to retrieve this value because it automatically starts from -1, -2, -3. Reason being, because -0 doesn't make any sense in mathematics. 0 we generally represent with 0 only. There is no positive and negative in that in majority of mathematical sequences. So here negative indexing starts from -1. So how we are dealing with it? I'm just taking this sequence to whiteboard and we are writing it here. So now in terms of negative indexing, if I have to write it, it will start from here, -1, -2, -3, -4, -5, -6, -7, -8, and -9. So this will be your indexing sequence if we have to access it with the minus or the negative option. Just different ways to access your data we are learning only. So when I'm asking you to retrieve this one, so index -3 we will use in that case. Let me know if this basic task is clear. Okay, great. Now let us use slicing with negative indexing. Slicing also we can do by using negative indexing, but in that case you need to be now more careful. Note that when I used positive indexing, we are starting from here to here. Based on that, we are counting and we are deploying our code. When we are working on negative indexing, the index values start this way. The index values start from last to first. But when we are retrieving elements, the Python program will take values from this way only, from your this sequence towards this sequence. Even if indexing values are given negative, still the reading process in our normal English language, in normal Hindi language, everywhere we follow from left to right. That is a normal reading process. So everyone understand this very carefully, otherwise you will get confused again. So steps we are writing here, and in these steps, if I use slicing with negative operation, for instance, I'll just remove this portion. And now I'll ask you to retrieve this data. This range of data I'm asking you to remove. Understand that reading process is going from this side. So with negative indexing, the start value is -5 and end value is -2, because the reading process is going this way, just the indexing sequence is different. So -5 and -2 will represent this intermediate data that we are looking forward to. Let me know if this concept is clear. Just index values opposite we are using, but the reading sequence is same. And also starting element will always be smaller than this. So -5 is lesser than -2. So that is why we'll first put this and then put this one. You will not write -2 to -5. That will not be right, because in that case the reading process is not valid. When we are reading from here, -5 will come first, -2 will come after that. So the reading process will not go. That is the natural process of this language reading. So now coming back to this, if I'm asking you to retrieve this proportion using negative indexing, give me the idea for this. What we should write using negative slicing in both sides for retrieving these 4 entries. Okay, I can see some responses. Let us try this only that you people are sharing. So I can see -2 to -6 to -2 answers. So observe the same number of elements we are retrieving, ranging from here to here. So that goes fine. -2 is this one. So we are always using one less than the last value. So I hope now negative indexing is also clear. Now we will take one step forward. It is even possible to use mixed indexing for slicing. Mixed indexing also we can utilize, where you can club positive and negative indexing together. In any proportion, you can use that. So let us try some basic example for this. Maybe I want to use these 3 values and I want to use mixed proportion of slicing. Positive, one side I'll use positive, one side I'll use negative between those columns. So let us see if we use it with the positive indexing, how would you like to write it? Just give it a try. In any of the proportions, you can use positive indexing. In any of the proportions, you can use negative indexing. I'll wait for a few more responses. I need one side positive, one side negative. Not same on both sides. Make sure that what I'm asking is use positive and negative indexing together in same slice. Just for the practice purpose, we are learning this. Okay, 2 -6, 2 -4 different answers I'm getting. Let us try any of these ideas. Like maybe 2 colon -6, one answer I can see. So if I run this, I'm getting only one value, this 7890. Any other idea? I'm getting, okay, -4, 2 colon -4. Yes, this is bringing these 3 entries all together. Now, observe this carefully and let me know if you can understand this concept. If anyone has confusion, I'm here to help. Let me know. Just check if you can understand this one. Yes, 2 colon -4 is working fine. Just calculate positive and negative both ways and then put your values based on that. So many answers got what is the utility of such mixed indexing? Yes, that is also a good question, because what happens, sometime we don't know the index of your values. Like you are generating very big list of data entries. Maybe you have created a software, any software where you are updating values continuously for patient vitals, like your clerks in the hospital or maybe on the registration desk, the patient vitals are being continuously updated. So in that case, you don't know what is the last value right now, but suddenly you remember that, okay, I made some mistake in maybe previous 2 3 entries, but you don't know the last index value, and these values are getting stored in the list. So in that case, negative indexing may help you. So complete negative indexing also you can use in those cases. Similarly, you can mix in it in some scenarios when the starting values, like that I need values from Wednesday onwards, and I need it from maybe last 3 4 values only. Up to that I need, because after that I have made wrong entries. So that if I skip just last 3 4 entries, up to the relevant values I'll be getting. So in that case, mixed indexing will also be useful for you. Yes, the last one we have used in that case. First one is the positive, and second one we are using negative indexing for the representation. That is why I have written here in this form that you have to use mixed indexing. Let me know if the point is clear up to this. Now, the next task we are doing here is updating list. Means if you have existing values in list, like we have taken many of the entries here, maybe I'll take up this glucose entry again. Although remember here that these variables are currently stored in your memory, so you need not to redefine them. There is no need to redefine them, but I'm just copying them to the recent cell so that your data stays in front of your eyes. Otherwise, you'll forget what we had here previously. But in general, this is already in your memory, so you need not to redeclare that. I'm currently using it for your ease of understanding. So that thing you should always have in mind. Whatever variables or lists, etc., you have declared once in this code, they are always present in your sheet until and unless you delete them or you close this sheet. So I'm just reusing this glucose variable. I'm just declaring it again here so that you have nearby reference to it. And now inside this, maybe while while recalculating all my data, maybe I came to know that this value I have inserted wrong. Maybe while I'm just collecting all my references back, I know that this 130 is wrong value, and instead of this I need to insert 128. So you need not to create entire list again in that case. Rather, you can replace this value directly by using its index element. What you can do, first let me know the index value of this 130. Use any positive or negative indexing, that is your choice. What you think is the index value is this 130 that we want to replace right now. Yes, index value, if we take the positive one, this is 5. So in order to replace this, I'll write here glucose, fifth index value I'll mark, and I'll replace it with 128, for example. Just index value I'm mentioning, and I'm updating new value that I want to address here. So after this, if I try to check glucose, you can see this value is updated now. Instead of 130, now I have 128. So maybe while collecting your data, suddenly you get a reference that for patient ID 6, you have made a mistake and the glucose value is entered wrong. So you know that the patient ID 6 is stored at indexing 5, and I can update it quickly by using this information. So with indexing, you can directly update that value. Try this if you can understand the concept here. I'm sharing this data right here. You can try changing any values now. You can use positive or negative, any indexing. I hope this is clear. Now I'll tell you three most important operations that we apply on index. I'll write here insert operation, that is adding elements by index. This is the first operation on list as an important category we are learning here. One thing I have shown you that we are updating values just by using index value directly. So the similar kind of activity, the similar thing I'm telling you, similar kind of thing we can do by using a specific function also. So we use a insert function for that purpose. So for instance, if I use any of the previous variables, like maybe this heart rates variable I have here, so this same variable I'm taking for reference to your nearest cells here, and I'm writing here heart rates insert function. Functions always come with round brackets, we have discussed that already. So this I'm writing, and I want to update third value, third index value, third index position with a new value. Observe what we are doing. Insert function, index and value. Two things we are updating. Index that you want to change, and value that is the new value you want to insert at that index. So these two things we are updating here. So after running this, if I try to check my updated heart rates value, you can observe this value is 102 now. So either directly by using index like this or by using insert function for more specific details, you can update your values like this. For any mistake in your data, you can update values quickly by using these functions. You need not to create the entire list again. Wherever you find missing value, just access that index number and insert that, because this happens very often with several researchers, that when they recalculate their data, they find that some values are entered wrong. So in that case, instead of messing up with entire data once again, you can just call those index values directly and update your new values at those positions. Let me know if this point is clear. Okay, great. Now I'll show you one more fact here, that this insert function works fine when we are using it with single value. Like I have inserted a single value here. But if I have a list of values to insert, in that case, let us see what will be the difference. For example, let us, before running this cell, I'll show you the indexing element individually here. Like I have updated third index, so automatically on third index now I have 102. This we have tested here. Now what I'm doing on this third index, instead of updating single value, I'm trying to update two values maybe. Just considering a case when you have multiple values to insert somewhere in between. Like maybe we can consider you are preparing a patient history, but maybe you could not find patient vitals for certain day, and you are still continuing with data. You are just updating your list, but someday later on, maybe after a week, you find his data that you were missing earlier. So now you want to insert that data at specific position back. You have already created your sheet up to that date, but backdate entry now you want to do. So you just have to find on which index I may have to enter that value, and you can insert a new list for that day for which the data was earlier missing. But if you try to do that with insert function, observe here. If you try to do that with insert function, it will insert those values as list only. You can observe list is inserted as list inside. What does it mean? If this time I put index value 3, it will retrieve both these elements together because they are getting single index now. This is offering them a single index, so they are not working as individual values right now, rather a combination of list they are working. So these kind of entries become list of list, but they not may not be useful in every case, because when you are needing separate data entries for every patient, like if 5 heart rate entries you have to make in a day, maybe 5 heart rate entries in a day you have to make, and when you are refilling that missing data of 5 entry for maybe previous Monday, so you want that they are inserted as individual entries, but this will make them a single entry. So applying your mathematical operation on this kind of value is difficult later on because this is appearing as a list. So I have shown you the benefit of insert operation as well as disadvantage of insert operation. First, let me know if this is clear. Disadvantage is that it is not giving them individual index entry. Rather, it is considering them together only. So later on, if you have to evaluate these values separately, it will not give you an access because it is not assigning independent index numbers to these two entries. So if someday you have to calculate something else from heart rate entries of that person from the previous Monday whose missing entries you have inserted by using this, you will not be able to operate on them because they are all coming together on that index value. They are not getting independent index values. Yes, I'll be showing you the solution further. First, we are just learning the pros and cons of different functions available. And what we have learned, one more point here, that insert function allows you to insert values anywhere in the middle of your entries. That is the important point you need to understand here. Anywhere in the middle of your list, you can insert new values by using index function, but it doesn't go well if you are inserting a list into list, then it doesn't go well. Two things we have learned from here. Now, I'll take you to one more function that we call append. This is adding elements by the end of list. Observe what I'm saying. Adding elements by the end of list. Before this, I was adding elements by index. So whichever index I select, at that position, I could insert values. Here, what I'm doing is adding elements by end of list. So maybe you are creating certain range of entries, like maybe I'm creating here a small list of patient names. So just some random names I'll be inserting inside this. So these 4 names I have inserted into patient name list. Now what you have is inside this patient name list, I'm adding one more entry. So one thing is you insert that by using index value. That is one option you can try. But other ways, because if I have to put it by the end only, no need to calculate existing indexing. I can use append directly without even knowing about existing index of my last element. Maybe I can add that element directly because I know that by default it will be added to the end portion only. So you can observe this is inserted by the end by default. So even if I don't know the index value of this to know that where I should enter, make next entry, if you don't know the index entry of anything, still you can put new information by the end of it by using append function. Append always adds new entry by the end of your existing list. Let me know if this point is clear. Okay, great. Now the same thing, I'll show you pros and cons of everything we are checking side by side, because these three functions are more commonly required by people who are using Python for data management. That is why I'm putting more emphasis on these three functions. So the same entry I'll try to do, like I have done a list entry here. So here also I'll try to do that kind of thing. I'll write here append, and inside this, I'll insert a list, for example. Or maybe I'll create a separate list of patients here. One list, just to make it clear with reference to your kind of data. For example, you have one list of patients suffering from diabetes. So I'm writing one here, and other list you have is from cardiac department. So different people are giving you list, and now your job is to collect it all together. So I can maybe have these kind of two separate entries. So the different departments are just giving you list. So you may have something like this. And again, you can just embed these two lists together. I'll put it here, and I'll use this one for the append purpose, and I can see the updated list now. In the previous list only I'm updating. If you can consider it in your case for the hospital environment, you can consider that maybe these patients were earlier in the cardiac department, but now doctors have analyzed that they are also suffering from diabetes. Now that data has come to you that these cardiac patients are also suffering from diabetes, so you have to update their name in the same list of cardiac diabetic patients. So that append we are doing here. But if I run again, the problem exists here. It is inserting those elements by the end of list, which is fine, but again as list, as complete list only. So if I try to access the last element, it will extract both of them together. Instead of giving them individual index values, it will again access both of them together. So the benefit of append is that it can automatically add new values by the end of existing list if you are updating one value at a time. So it can automatically add those values by the end of the existing list. But the disadvantage is that if you try to collect two lists together, so the second list will always be treated as a single element in new entry. So it will receive single index value again. Let me know if the positives and negatives of this function are also clear. Let me know if what doubt you are having here. Just a similar pattern we are using, that both of these functions are good for inserting individual elements, but for list entries. You can see this is also getting, you can see the brackets now, brackets can are more visible. These outer brackets belong to your main list. These inner brackets belong to your inner list. So this entire thing is getting single index element. But in actual, this should have -1 indexing, this should have -2 indexing, but that is not happening here. So that is the disadvantage of append function also, because both of them are getting single index entry again. So the best solution to these problems, although these previous functions also have their benefits, but to deal with all these problems altogether, we have one more technique here that we call extend, adding list into list. Although it has other functions also, like single elements also it can enter, but this is more useful when you have to combine two lists together. So what I have here is, I'll take this one again considering the same hypothesis that you just have to combine patients from two different departments, and instead of append, this time I'm using extend. I'm just replacing append with extend this time, and remaining all things I'm keeping as it is. And after that, I'll see the updated list of I have made a spelling mistake over here. So I'll just correct this one. I think earlier also it was like this. But we just need to make sure whatever variable we have earlier declared, the same we have to use. So just make sure that. So these two entries I'm using. And this time you can observe. Can you feel the difference now? Yeah, that's great. Now we can see them without inside list element. We can see their individual existence. And for this, if we try using the index operation, whether positive, negative, any, you will see that you will be able to retrieve now individual elements instead of combined elements. So this gives individual priority to all the elements together. So this you can see now. So they are now part of existing list instead of being treated as an um, anonymous values in your entry. Now they are becoming part of the initial list. So now, because when you have gathered new patients from the cardiac and they have to be enrolled into the diabetic center, so you have the entire list with you and you can plan their treatments individually now. You can access their values individually now. Let me know if these three functions are good to go now. Now, other than this also, there are plenty of activities that you can conduct on list. I'll not take it much into depth because we have few more concepts also to learn in the session. So just one or two activities I'll show you here. For instance, in your existing list, if you want to know how many entries are there, because that will help you to understand how many indexes you will have automatically. So in heart rates, if I see length of heart rates, it says that there are 7 elements. And if we want to verify that, we can see this was our recent heart rate element. I think this one we have updated with insert. So 1, 2, 3, 4, 5, 6, 7. It is containing 7 elements right now because this entire thing is getting single entry only. So it is showing that currently we are having 7 individual elements in heart rates. So with the help of length function, we can calculate how many total number of elements we have in certain list. This is check total number of elements in a list. For this, we can use length function directly. So when you are inserting patient values, maybe you are just rigorously inserting your patient vitals, and then someday you want to know that how many entries I have made, like how much data I have collected. So this length function will quickly help you know that how many entries you have made already. Similarly, there are many other operations that we can do on this. For example, I'll take up any numerical list like this again. I'm just taking it nearby for the close reference. And from here, I need to check the minimum and maximum values, like to check any of the consequences available in our data. The minimum values, I can see this one is the minimum value. Similarly, we can observe the maximum value as well. So for that, just max I have to write in front of it. So there are direct operations for everything. If I run this, it will calculate the max value also from your list. Several direct mathematical operations we can easily apply on lists. Try this and let me know if we are good with the list. Then I'll go to the dictionaries part. I'll wait for responses in the chat box. I hope others are also clear with it. So the first reference for dictionaries I'm adding here is that dictionaries store key value pairs. Some keys and values for a structured data we can insert into dictionaries. Let me give you a better reference of this by creating a dictionary. For example, patient details we want to organize somewhere. So first day, when the patient is coming, certain details we may be inserting for that patient. And later on, we can update those details also. So on the day of registration, for example, we are assigning a ID to that patient. So that will be the first information we are getting. So ID in front of this, I'll be putting 0112, for example. This is the patient ID I'm getting. Then from the registration form, I'm also getting name of the patient. So any random name I'm updating here. After this, registration form will also provide information on age of the patient. So that also I'm updating. Then the initial condition of the patient, anything reported. So for the treatment that will be useful. So I'm writing here diabetic, true. That they have reported that they have diabetes. So I'll write here true. Similarly, few more vitals maybe you are getting from initial reports of the patients. So that also as key pair values I'm storing. So I'll write here maybe value 92. And then temperature information also initially you are getting maybe 99.5. So this becomes now your dictionary that contains all necessary things about a patient. That could be any patient. You can save that with the specific name or any reference detail. But this is the way to organize all details about a patient altogether. Now, whenever I'll access this patient, it will provide all relevant details associated to that patient to me. This is a way to organize your data or patient information at a single place in an easier manner. And I'll also show you how you can update these values further. First, create this basic list and let me know if this storage technique is easy to understand for you. How we pronounce it technically, this we call key, this we call value. So before colon, we call it a key, and after colon, we call it a value. If I try to access name, it should retrieve Rahul. If I try to access age, it should retrieve 45. That means here, if I try to insert patient and inside this, if I insert the specific element that I want to retrieve, maybe age, so it will show me that patient age is 45. Key value pairs we have together. So the reference elements of the variables and the specific values, we can place everything at a single location. Let me know if this sequence is clear. I have shared this in the chat box also in your code share window also. So you can first try these things and let me know then. Yes, this is very different from list because lists are generally when we are doing it for the single range of elements. But when you have so many things associated to a single person or maybe single employee or maybe single patient, then dictionaries may be a good thing for you. You can store every reference details of that patient at single place in this case, like entire history of the patient can be placed at a single place and you can just call it by that reference variable anytime and it will be in front of you. Like maybe you can store this thing by patient IDs also. So when you put a specific patient ID, all information about that patient ID will be in front of your eyes quickly. Let me know if things are clear up to this. Then I'll show you an interesting thing about dictionaries further. Now, think here That, for example, during the first visit of your patient to your clinic or hospital, you have collected this information from that patient. But during the next visit of that patient to your clinic, maybe you are retrieving some new data also. So in that case, you may need to update new information to your dictionary. So what we can do is we can even add new fields to existing dictionaries. That is also possible. We can add new fields to existing dictionary. For example, I'll call that same patient dictionary here. I'll write allergy. Maybe in the next visit, he told us that such and such medicine you gave me last time, and I had an allergy with that. So now you can know that, okay, this patient has allergy with such and such medicine. So maybe we are putting that in our list. So maybe I'm writing that the patient is having allergy from penicillin. So that information maybe I need to put in my database. So I'll just update it with this value, just new value I'm inserting. This time, note that I'm using equal to sign because now I'm updating value to the existing list. Here, I was creating entire list in these curly brackets only. When we are putting it in curly bracket, observe for dictionaries, we always use curly bracket. Curly bracket itself will define that this existence is for a dictionary. So when it is within curly bracket, we write it with the colon in between. But when I'm directly updating new value, I'll use equal to sign here. So I just updated this allergy information. And interestingly, now you can see that if I access my patient detail again, there is one more key value pair now. So any number of visits your patient have to your clinic, every time you may have new patient data summary, you can keep on updating it into your existing list easily. Let me show if this is useful for you. I'm sure this will be many times useful for your day-to-day operations as well. So there could be hundreds of visits of a patient, and every time you may be retrieving a new data, you can keep on updating the same dictionary, and entire thing about that patient will be ready at one place. You will be able to access it anytime. And now I'll show you one more path here. For example, I have shown you here that in the recent updated patient information list, these are the general values. But maybe in some next visit, certain value you want to update from the existing ones. That is also possible. Maybe you want to change SpO2 value from 92 to 95. Due to maybe some observation, you feel that this value should be changed. So what we can do is, I can just call this specific element. I'll just write SpO2 and I'll assign it a new value. And after that, I'll check my updated patient list again. You can see the new value is 95 now. It is even possible to change any existing value as well as add a new value into your dictionary as per requirement. And accessing any of the information is also easy. Like maybe someday if doctors need to know that, okay, for this patient, what were the allergy issues, so they can just access the allergy issue, and that will be quickly updated on their screen that, okay, the person is suffering from penicillin allergy, instead of checking the entire document, because in a single dictionary there may be hundreds of entries. Can we say previous values and the new values also? These are all getting saved into the same patient list. This is automatically getting saved. Whenever you are making a new entry, that is automatically getting saved in the existing list only. So previous values are also there, new values also are getting into the same list. And you are even updating those existing values as per your requirement. Everything is possible in a single dictionary itself. Like earlier, this was value 92. I updated it to value 95. So the previous value I have updated. But yes, both values together, if you are asking that if we need 92 and 95 both together, that in this form is not possible. In that case, you may have to store a list within dictionary. That is possible. You can store a list within a dictionary. That kind of thing we can do. For example, I'll show you one thing. Maybe we'll make one more entry here. Like I'll add here patient details, and maybe we'll have any random information. Maybe I'll write, for instance, visit days. We are updating like on which day the patient has visited to our place. So what I'll do here, I'll create another uh, list here inside. So I'll say that, okay, the patient visited on Monday, and then they visited on Wednesday, and then they visited on Friday. Maybe three things I want to update in sequence. So I'll just run this, and then I'll check this patient information. And you can see I can store even a list inside. Multiple values we can hold together. Now, if I need to access certain value inside available list, that also further you can update as per the list entries here. And then after this, I'll show you one more part. There is several interesting things that you can do with the dictionaries. This is one of the most amazing type of data structure you will find in Python. Like, for example, I'll give you one general sequence here, just not considering the patient details, but just a general thing I'm using here. Like for that person, I'm saving information about pets, not relevant to the medical detail, but just a general example I'm giving you here. So maybe the person has two types of pets. One is dog, one is cat, but you want to store that information with the name of dog and name of cat. So what I'll do here is dog and his name. For example, dog name is Fido, and the cat and the name of the cat. So I'll write maybe Catty is the name of cat. So we can even store further key pair values in the same. I'll run this, observe, and here I'll check again my patient dictionary, and you can see everything is getting updated. So dictionary inside dictionary can be also saved. And with this, I'll show you one more interesting part from this patient list. Now, if I need to know, maybe out of pets, I need to know the name of dog. So I'll write here, among pets, I need to know the name of dog only. So I'll run this, and it will extract this element only directly. Observe how it gives you access to the inside elements also from the list, from your dictionaries. Let me know if this is useful. Please show the above codes in the screen. Okay, I'll just update. Which one you need, let me know. This one is fine or previous to this? Pet entry. Okay, fine. This one I'm showing here. Just a dictionary within a dictionary I'm creating. You can observe why I'm calling it a dictionary. You can see this is within curly brackets. Okay, see, I'm creating a dictionary here. These curly brackets are showing a dictionary presence. And then I told you that dictionaries occur in key pair values. So dog is the key and value is Fido right now. Similarly, second key is cat and value of this is Catty now. So when I'm accessing from the pets section, I'm extracting the first element, then it is retrieving this one, because the outer key is pets. You can see outer key is pets, but within pets there is one more dictionary. So the inner key is dog right now, and I'm extracting value of this directly. If I extract only pets, for example, if I use only pets section, then it will bring the entire dictionary. But in order to access dictionary within dictionary, I can use the internal key also, and it will then extract this element as it is. Let me know if this is good for everyone. So with this, I'll move to the next type of data structures that you may need sometime. Tuples, although they are not like very commonly used in Python, but sometime you may require. So I'll just give you a quick example of tuples only, not very detailed, but we will just learn a basic of this. So I'll write here tuples in Python. First, creating tuple, I'll write here. Note that, okay, I'll put this code in the code share also. Which section you may need. Okay, this recent one I'll update. So a few essential entries that I have made, I have updated then in code share. If you need more, let me know. I can help in that also. So here we are talking about what are the tuples. So tuples are also a kind of list. Try to understand the difference first. They also are a kind of list. They help you to store a range of elements all together in a single variable. But the main difference is that you can change or alter values of a list, but changing values of a tuple is not permitted. Tuples are more like fixed data type. Once you have created, they cannot be changed or they cannot be updated. You can just delete the entire tuple, but you cannot change or hamper its inside elements. So when you may need them, for example, list you may need when there is a possibility to update it later. Like you need to keep a possibility that if there are any mistakes, I can change it later on. But in the current case for the tuples, this is for the final version of your data, after which you don't want anyone to change anything in it. You make a fixed sequence and you don't want any interruption in that data. So tuples may be useful in that case. So what we call them, like in case of list, I told you that lists technically we call that they are mutable. For tuples, technical terms we use is that tuples are immutable, means they cannot be changed. They are fixed data type. And how do we create tuples? For example, any random tuple I'm creating, so tuples are always stored within round brackets. Three types of brackets I have used today. For list, I used square brackets. For dictionary, I have used curly brackets. And for tuples, we use round brackets. So accordingly, the access will be provided within your memory, and accordingly, Python will react to these storage types. So I'll just run this, and now these tuple values are stored. You can see inside this variable, there are 4 entries. First, create your tuple like this. Then I'll show you essential operations on this, like why I'm saying that this cannot be changed or updated. Let us try to change or update a value from a tuple. So if you remember the list part, we were able to update list entries using index values. There were many operations that we tried, but I'll use just one or two of them. For example, inside this tuple, I'll just try to update certain value. So what I'll do is I'll write here position 2 and I'll update it with a new value 9 maybe. I'm trying to update this with a new value 9. This we have done in case of list. We have seen that this works fine. If I do this kind of operation on a list, in that case, this second position element means 3. 3 is your second index value. So this will be updated to 9 in that case, in case of list. But if we try to do this on tuple, you see, you get an error. Tuple object does not support item assignment because it doesn't permit you to change anything from the existing entry that you have created. Once you have saved your data in the form of tuple, you are not able to change that. That is the final version of data you are getting. Similarly, you can try some other things also, like you try to delete something from a tuple. Like someone is trying to hamper your data and certain value they are trying to remove. So maybe I'll write here delete operation and I'm trying to delete second index value from my tuple. So I'll run this and it will say tuple object doesn't support item deletion. So nothing can be changed once you have created your storage in a tuple. Let me know if this is clear. Okay, great. So otherwise, the normal min and max operations or other normal mathematical operation that are not altering anything from your tuple, that kind of thing we can apply. Like if I have to check the minimum part of tuple, it will calculate. Similarly, if I have to check the maximum part of tuple, that also it will calculate. Normal operation, it will do. But if anything is we are trying to alter, then it will not permit access because it is considering that final version of data that should not be hampered by anyone. Okay, in order to know it again, I'll just explain this part. Observe here, I'm comparing tuples with the list importantly because they are used in different consequences and their storage type is almost similar. So see, in first I told you the difference between brackets. When we were using list, we used square brackets. When we are using tuples, we need round brackets or parentheses, we also call them. When we are using dictionaries, we use curly brackets. First differences in terms of different brackets that we use in these data structures. Then I told you that once you have created a tuple, you cannot change any of its existing values, or you can not even add new values. Whatever once you have created, that will be the final version. Once it is created, you cannot change anything from it. Like I told you that tuples are immutable. Technical term we call is tuples are immutable, means you cannot change anything from the tuples. However, in case of list, we have seen several operations. We inserted new values, we appended new values, we extended new values. So everything was accepted there. But those kind of things are not possible in case of tuple. So once a tuple is created, it will store your values securely and they cannot be altered by anyone. Let me know if that point is clear. If you are still confused with anything, let me know. So what we are trying to do here, I'm trying to add a new value into tuple at second index value and it refused. It says that tuple doesn't support this type of item assignment. Similarly, I tried to delete certain element from my tuple. Again, it said that you cannot delete anything from tuple. Means any alteration on the tuple based storage is not permitted. However, normal operations we can do that are not hampering any value from your storage. Those kind of operations we can do. Maybe we can check minimum values, maximum values, or other normal operations from where you are extracting some details. Those are possible on tuples. Yes, you can store your data safely with the help of tuples. That is a better way to use. Now, let us, because the basics I have told you for every part. Just to gain more confidence on what we have learned today, we will do little bit of practice now on the concept that we have learned till now. So we will do here some example exercises. So first task we will try to do here, I'll give you just basic task only so that you can just refresh whatever we have learned. We will write here, create a patient dictionary with name and temperature readings of, or in simple terms, I'll write here, and 5 temperature readings of the day. Like maybe in one day you have gathered 5 temperature readings of the person, or the day factor is basically not important. The point is that 5 temperature readings you have to enter for that person. Maybe one day a person came to you in your clinic, you just had him in under observation, so you are now storing his data. So you are first storing your patient name, and then the readings for the temperature for that day you are storing. So this is your first simple task. Just create a very basic dictionary and show me how name and list of these 5 temperature readings you can store at a single place in a dictionary. I'll wait for responses in the chat box. Give it a try. Otherwise, I'll help you. I'll wait for a few more responses. It looks fine. Others also give it a try. I hope others are also trying to do the same. So I'll just take any one of these examples. They look almost similar, so they are all fine. But just for the demonstration, I'll pick one of these. I'm just changing these curly bracket, these quotation marks, because during the copy process, the format may change. So I'm just updating this, and the format of these brackets also I'm updating. Observe one thing here, you may need a comma at this position. A comma may be required at this position to start with the next line continuation, like I have shown you in the previous cases. While storing your patient details, you can see a comma we need after every entry. Then only it will be able to separate your unique entries. So a comma may be required. So I'll just run the section that you shared, and this goes fine. We can, after this, we can check these patient details easily. So these 2 entries we are having from our data. First, name information. Second, we have is temperature details of that patient. So I hope this one basic entry is clear to everyone. Now, next thing, we will do a simple operation further on the same sequence that you have created. For example, I ask you to find average temperature of patient for this day. You have already made entries, like 5 entries. Maybe you just took patient temperature 5 times a day. And now you need to know the average temperature of this patient for the day. So we can do such type of operations also directly on the list. Let me show you how we can do that. For instance, the task I'm running here is, first is I need to go to the patient part. Then I have stored these values with the temperature. And in order to calculate average, the general formula we can apply. So what I'll do is sum of patient temperatures divided by length of patient temperatures. Like this portion, I'll pick up this. This is a formula of average that you can generally apply. And I can make it more precise by utilizing the knowledge from previous sessions. I'll write here average temperature of patient. And after this, we will insert this portion. So now you can observe what calculation I'm making. I'm just trying to calculate average temperature of the patient by using formula, sum of all the reading divided by number of all the readings. So length will give me the number of readings that we have tested already with the list also. Length I have shown you earlier. So if I do this, you can quickly see the average temperature of the patient. So maybe you calculate 10 readings of certain vital, 50 readings of certain vital in a sequence, then you need the average of that. You can now apply any formula. Even on the dictionaries directly, the formulas are applicable. I'll share these both sections with all of you. Give it a try and let me know if you are able to understand this point. Any type of normal mathematical operations you want to do, you can directly apply that on stored values. I'll wait for responses in the chat box if everything is fine. Question I have given here, the task I have given right here. Create patient dictionary with name and 5 temperature readings of the day. So we have solved it in this manner. Patient information with name and 5 readings of temperature we have inserted. And after that, I asked you to calculate average temperature of the patient for that day when we have calculated 5 temperature readings of that patient. So for that, I directly applied normal mathematical formula, that is sum of patient temperatures divided by number of readings. So that only we are calculating here for the average temperature of the patient. Let me know if this is clear. Now I'll give you a simpler version. Observe the statement that I'm providing here.
Madam, can I speak?
Yes, please.
Why in the code, after that average temperature of patient, you have given a that is within inverted comma.
This one.
Huh.
Yes.
And then there is a comma, and then there is a formula.
I suppose we have also done this in previous session. What we are doing here, I told you about static and dynamic text earlier. So whatever we keep within inverted comma, that is a static text that will be printed as it is. This portion is printed as it is, you can see. And this portion involves dynamic values. So it will calculate those values. It will first calculate sum of patient temperatures. It will then calculate length of patient temperatures, then apply formula, and then get that dynamic value. So the portion that is static, that is within inverted commas, and the remaining portion is openly created.
Thank you.
Okay. So the next task I'm inserting here is a simple thing you have to do is I'm giving you a hypothetical scenario. You just think about it and then give me a solution. For example, during first visit of patient, they reported two symptoms. And for example, those symptoms were fever and cough. For example, two symptoms they have reported. You have stored those symptoms in your device. I'm not giving you the storage method. You have to choose that yourself, which storage method you will use. We have learned different data types. And then during second visit, patient reported one more symptom. That is maybe fatigue wheel right here. Maybe one more symptom they have reported now. During second visit, the patient reported one more symptom. You have to update this new symptom to the existing entries now. This is a scenario, a hypothetical scenario I'm creating for your task. Just try it. If you can understand what I'm asking you to do, just give it a try. Don't worry, right or wrong. Just try to understand the concept and give it a try. How you can store these values, which data type you will choose, and how you will update new entry to it. It will be just a 2-3 line simple code. I'm just giving you a hint of that. I'll wait for a while. You need to create both types of entries. Observe, there are two sections of the task: data of first visit and then data of second visit. Two things we have, and we are talking only about symptoms, not other details of the patients, just the symptoms we have to update. First visit symptom, and then he comes next time, the second visit symptom also we have to put in the same sequence. Do not consider any of the existing variables that we have already created and used. Use your own variable and use the updation in that only. This is a very simple code. You just have to understand the logic only. Is anyone giving it a try, or I should help? Great. I can see one response. So the simplest form to use the hypothesis that I have given is it may appear something like this. Like first you created initial patient symptoms and then you just appended the last symptom into the list. This is the simple execution of the hypothetical condition that we have created. I told you that you just have to store these two symptoms and then update these symptoms. So updating process, because this is the next symptom in the sequence, you can directly append it to the existing list. So that will be the easiest, most solution you can create. Yeah, that because we are learning multiple data types, so it may create confusion initially, but we can find the easiest possible way to do things when we have such type of situation. So we are just learning right now. Don't worry if you are confused at initial stage with anything. When you practice more, you will get better clarity on the topic. So we are already on the verge of the session. I'll not take it any further. I suppose I have given you some relevant details from today's session also. Let me know if it was good for all of you. Have you learned something new in today's session? Yes, it is possible to append it into the list, into your existing dictionary as well. No problem in that. You can use it there as well. But preferably, what we are doing right now, we are not using any existing patient information. We are just creating one new variable because this was a whole new task I have given you. Otherwise, indeed, you can update it into dictionaries as well. You can use append operations on the dictionary list as well. That is also possible. So let me know if we have any queries, any discussions, any feedbacks from today's session. The house is open for all of you. In your second code, you are using patient as your dictionary variable. In your first code, you have declared it as patient2. Try again. Other participants, let me know if everything is fine for today. If you need any help or any queries are there, I'm here to help. Otherwise, we'll wind up the session for now. Okay, great. Thank you very much for your patient listening. We'll meet again tomorrow at 6 to learn more. And in tomorrow's session, we'll also have some GUI interface type things. So whatever we have learned in first 2-3 days of Python implementation, that we will practically utilize tomorrow to create some kind of GUI that is interactable thing. So that will be more interesting to learn for all of you. Thank you very much, everyone. Be on time tomorrow. There are many interesting things to come further.